Hey everyone, Jay here, and today we're going to be looking at another Python lab example, and we're going to be playing around with random numbers a little. I have a few small examples for you, and we're going to do a couple the easy way and at least one the hard way, which would be a little bit more universal. You could use it with other languages outside of Python. And then we are going to use at least one that is specific to Python as well. So let's get started. Uh, you can see I've got my code started here, got my comments and everything as usual, and I'm importing both random and math, although I might, yeah, I think I'm using math as well. We have to import random because we need something to generate the initial random numbers. Random numbers have been, without the random number generator, they're kind of a problem in computers at all times because how do you program something? Your program file is a static, unchanging file. How do you make a random number? In general, we grab the time that from the internal computer's clock and we generate a number based on that. And then every time you run it, you'll get a different number. So we have a random number function and the time is the seed or the initial value. And it's not just like the time in minutes or in seconds, it's down to the microsecond or whatever it is. So you'll truly get a different number every time. And although it is possible to kind of figure it out with some advanced computers and some advanced techniques, perhaps for the most part, you're never going to know what the outcome is going to be because you can't figure out exactly what the millisecond is going to be at any given time before it happens. So it's random enough, but for some really advanced purposes, it may not be quite enough. If you want to learn something really cool about random numbers, I suggest you look at how a company called Cloudflare takes care of its randomness. They use a wall of lava lamps, which is really cool. So if you're interested in that, look up Cloudflare and lava lamps and read a little bit about that. Anyway, let's jump in here. We're going to be creating some of our own functions, very simple functions, and calling them and outputting their numbers. So the first one I have here is going to be something I'm just calling random simple. I'm going to output a message that says the simple random number is, and I'm going to plug in whatever that number is. So let's have a look at that function. Random simple right here just uses the built-in random.random function, and what it's going to do is output a floating point number with a bunch of decimal points that is somewhere between 0 and 1. And so it's going to be somewhere between 0 and 1, a lot of decimal places. And in a moment when I run this and show you the output, we'll see what that looks like, but that's all it does. And with that decimal between 0 and 1, again, many decimal places, so you could do quite a lot with it. Looking at my last run right now, 15 decimal places. That's how far it goes in this run right here. Now that's just the output. I couldn't tell you if it actually has more or less than that without digging into it. And honestly, I'm not that interested to know if it goes more than 15 decimal places. That's plenty enough for me. But that's how far it goes. So my random number that I rolled last time is 0.702730680078166. And if I run it again, I'll get something entirely different. Now it's 0.1, yada, yada, yada. Yeah, let's see what that looks like right there. That's this number right here. Pull my screen back down. And So that's the first one, is just we're going to use that simple random. In other languages, it might just be called rand or random. But generally speaking, this is the common random number generator. You'll get some decimal between 0 and 1 in many languages. That's what you'll get. It's not quite universal, but it's pretty close, and you can expect that this function exists somewhere in your language that you're using. So the next thing we're going to do is take that number and actually do something with it. Here I'm calling my next function called random advanced. So let's take a look at what random advanced does. This is going to do use that same random.random right here. Okay, but the goal here, we'll talk about what this is supposed to do, and then we'll go line by line what it actually does. The goal is to give it a low value and a high value, a min and a max, or a start and an end, however you want to do, however you want to think of it. And it's going to generate a random number within those two values, and I've specifically made mine to be inclusive of those two values. So if I give a low and a high, I could get the low, I could get the high, or I could get any integer in between those things. Now, you don't have to make it inclusive of both. It is entirely possible that you make it exclusive of both, or just inclusive of one or the other. And generally, all you're going to do is plus or minus 1 in a couple different places here, and you can change that inclusive or exclusivity of the high and the low numbers. I specifically wanted mine to be inclusive of both, because at the end here we're going to simulate rolling a whole crap load of dice for a D&D game. We're just going to roll all the dice all at once. A super simple random number program. So like if you are a D&D player, you can just say, all right, I'm going to roll all the dice and just only use the ones I care about for this particular turn. And you can roll duplicates of dice, and it will re-roll the dice, so you only have to click one button and you can do the entire set if you like. So that's what we're going to use this function for in the end of this video. But for now, let's have a look at what it does. Right, so first I'm defining my function, random underscore advanced, and I'm taking two arguments. I'm just calling them x and y. It could be min, max, start, end, high, low, or low, high, whatever. I'm taking my two arguments, and I'm going to get the full range of values plus, but this is the full range of values, the difference between the high and the low. Okay, so what this is, let's say I'm going to pass it up here in my example, I'm passing it the numbers 5 and 32. So I'm going to get a random number from 5, could be 5, all the way up to 32, could be 32, or any number in between. So I need to know what that range of values is, because that's actually what I'm going to multiply for my random number generator. So my random.random is going to give me something between 0 and 1. If I multiply that value by the possible range, that's the difference from high to low, then I'm going to get a number in that range, not necessarily in that range, because my starting value isn't always 1. But then if I add my starting value in at the end, so I have a random number within a similar range, and then I add my starting value, now I have a number that's actually within that range. So if my starting value were 1, I would just be adding 1 at the end. But if I wanted to, let's say, get a random number between 0 and 99, in the end, or in the beginning, I would get my difference. What's the difference between 0 and 99? It's a difference of 99. I'm going to add 1 because I want the possibility of getting the exact 99 value, right? So I need that difference. What is the range between the high and the low? And then I'm adding 1 so I can get the possibility of getting the highest value. So once I've done this and I've got my difference, what I need to do is I'm going to kind of start in the middle of this, from this line here. and say my random.random, that's my random number decimal between 0 and 1, multiply that by the difference. So if I'm going from 0 to 9, my difference might be 7, and I have my decimal point times 7, so it's going to give me lower than that number, right? Because it's very rarely going to be a full 1 right here, or 0.9, right? So I'm going to get a decimal value that is somewhere within this difference range, and then I'm going to math.floor that. I could math.floor the entire thing, but yeah, I should probably just do that, right? Doesn't matter, I guess, for this because I'm only using integers, but I'm going to math.floor, which means I'm going to round down to the nearest integer, and whatever integer I get. So let's say my difference, let's say I'm actually doing 5 to 32 up here, okay, right here. I'm doing from 5 to 32. So 32 minus 5 is 27, plus 1 is 28. My difference could be anywhere from 1 to 28, and or from 0 to 28 actually. So I'll just say that it's 12. So get up at my difference here, pretending that it's 12. My math.random, let's pretend that it is 0.9 something. So the math.floor result will be 11. Okay, we're going to round down and it will be 11. So next I have my 11 be adding the original 5 starting point. So 5 plus 11 is 16. This would return a value of 16, which is definitely in between 5 and 32. Let's give an example of the highest and the lowest that this can be. So I have 5 and 32. I get my difference of 28 again, right? 32 minus 5, and then plus 1. So if I have 28 here, my math.random were 1, I would have a value of 28. 1 is the highest it could possibly be. I would have 28. It's actually going to be 0.9 something. So the highest it could be rounded down would be 27. And then if I add 5, that would be 32. If I get the lowest possible random number, 0, 0 times anything is going to be 0. The math.floor, round it down to a solid 0. Even if I get 0.1 or something, right? And if I add 5 to that, I'll get 5. So the lowest I could possibly get is 5, which is my low number. The highest I could possibly get is 32, which is my highest number. And if my random number is anywhere in between 0 and 1, which it's supposed to be, I'll get some number in between those, but I could still possibly get those as long as I get a number that's close enough to 1 or close enough to 0, because it is going to round. Okay, so that's random underscore advanced. And this is generally the way you're going to build a random number generator if you have to build one that selects from a low to a high. And this is generally how you're going to do it. You could probably get more creative, but you might make more work for the computer and slow things down. So that is that one. Okay, it seemed like a lot, right? And in many languages that is a lot. In some languages, Python being one of them, they have created the function for you. We're going to call it random underscore int. We're going to give it our x and y. I'm going to give it that same 5 and 32 in my example. And I'm going to call random.randint, give it those values, and it does the work for us. That's it. We're done. And so the advanced one, we did the math. We had used math.floor. We have called that. We called it random. And we did the math, and we got any random number from our low to our high. And then the second one, we let Python do all the work. And we just said, hey, I'm going to call this random int function. give it my low and my high, and done. That's it. Robert, your father's brother. You're done. All right, and last one, random choice. This one is nice. I'm going to create a list, my list, put in a bunch of drinks that I might drink on any given day. Now you know everything about me. These are some drinks that I drink. And then I will print out the drink selection here. So if I'm thirsty but I don't know what to drink, I put this list and I run it, and it's going to randomly select one of these drinks. And how do we do that? So Python has built in random.choice. You give it a list and it will pick one. Okay, now we didn't do this one the hard way because choosing things from a list is kind of a thing that Python specializes in. So we're going to definitely do this one the easy way. And for this assignment anyway, I think that doing one thing the hard way is probably enough. So built-in Python function random.choice will make a selection from a list. You give it a list and it will pick one. Okay? That is done. So those are the four kind of functions that we created here. One done the hard way, and then three others done the easy way. And then lastly, because we did one the hard way, and I really want to make good use of it, I have written 10 print statements, all calling our random advanced for D&D players. All right, so D&D players generally they'll have like a 7 die set. They'll have one of each of these dice and two 10-sided dice, so they could do percentages with the two tens that have the digits. There's a way to know which is which. If you play, you know. And so this simulates that. So some players may have multiple 6-sided dice, either 3 or 4, depending on their preferences. So I've included all 4. If they're not using the 4th one, they can simply ignore it or edit the code if somebody was actually using this. But what this is going to do is simulate calling our random advanced function that we made earlier and call that for each of the dice that would be used in a D&D game. And you could just roll this every time it's a turn, and yes, no turn is going to use all of the dice all at once, but for simplicity's sake, we'll just programmatically roll all of them all at once, and then just use the ones that you need for that turn, ignore the rest, roll again on the next turn, and do the same thing. So this is going to roll a 20-sided die that counts the numbers from 1 to 20. A 12-sided die counts numbers from 1 to 12. To a 10-sided die, number 1 and number 2. Two 10-sided dies. 10-sided dice are a bit unique in the dice family. They count numbers from 0 to 9. They are the digits. Okay. So if you have a first one and a second one of these is going to be the tens place, one of these is going to be the ones place, and if by chance you roll a double 0, generally that's considered a 100, and therefore there's no way to roll 0, even though the dice go from 0 to 9. One 8-sided die from 1 to 8, like I said, we'll have 4 6-sided dies. All right. You only require 1, but for convenience sake, some people have 3 or 4. And then one 4-sided die, which is the least favorite of everyone, apparently because people step on them and hurt their butt. Also because it doesn't roll very well because it's a triangle shape. But those convenient outputs for any D&D players. And then let's actually come and take a look at some output here. So remember our first function, the simple random, all it does is call this simple random function here, right here. Try and get that right on the screen. Remember we called random.random, and we got a number between 0 and 1. Well, that's that number. Okay. every time we call something, we do get a slightly different number. So if I called random.random and I just kept calling it over and over and over again really, really fast, I would still get a different number because there's no way that this function could be called twice during the same millisecond. It's just computers aren't really that fast. You can't call it twice in the same millisecond. It's going to be at least 1 millisecond later, and then it will be a different number because of the way that it's generated. It will be an entirely different number with an entirely different, it's not just going to increment by 1 or anything like that. It will be very different. Our next one, this is our advanced one, we're calling and we're giving it a number between 5 and 32. In this case, it got to be a 31. Right? If I run this enough times, I will eventually get a 32 and I will eventually get a 5, but it won't get 33 and it won't get 4. I'll only get numbers in between there. I did test this out. Basically, I just copied and pasted the code 5 times so I could multiply my chances of seeing the numbers. I ran it over and over and over again, and that's as high or as low as I got. So it's accurate. Next one, random integer. Okay, this is when we are doing things the easy way and letting Python do the math for us. Next one is random choice. Again, we're letting Python do things for us. We give it a list and we say, give us a choice. So my drink selection is water. Sorry, Python, I'm having a protein drink. I'll have some water next. And then at the very end, okay, I have my if name equals name function, right? If name is defined. I don't have any more functions. I'm just doing my D&D rolls at the end, and I've kind of cheaply formatted them right here so that all the numbers pop out at the end. And let's just run these. They are random number generators after all. Just gonna run these a few more times so we can see. Right, I got 31 again right here. All these numbers are different. Couple of ones. That sucks. Right? Let's just keep running these a couple of times so you can get an idea of just how random they are. All right. Great. So that's random numbers. There are a few more things that random can do and a few more things that are built into Python, and you may find some things in other languages as well. But if you can do the advanced formula that we did, then you're pretty good to go in most cases. You have what you need. You can generate a random integer between any two values. You could take the floor off and you could get a random floating point in between values. Okay, so you can do that. You need to do that as well, and you should be pretty good to go in most cases. That's it. That's random numbers. Thanks for watching, and I'll see you next time.